All right, everybody. Let's go ahead and get started on this March 23rd go-to meeting. We're a little bit more than halfway through the semester now, so on our agenda for tonight, we want to talk about what's due. You all should have received your midterm back, so we want to talk about the midterm a little bit, how I graded it, and some commonly missed questions, and then let's talk about the Where Are the Jobs lab. Okay, so specifically moving forward, what's due this week? We have Section 2.1 due on WebAssign. Read the text, watch the video, and then we have the Where Are the Job Labs due on Friday, 3/27 in Dropbox. So the WebAssign Section 2.1 is due on Wednesday, and the Where Are the Jobs Lab is due in the Dropbox on Friday. If I just pull up my Moodle, you can see I posted the Unit 3 stuff on Moodle, all right? And I'm going to encourage you all to do this. You see how I can move this arrow around, and if I have it pointing down, it shows all of Unit 1. Since we're done with Unit 1, I'm just going to put it on the side there so it doesn't show all that, so it kind of unclutters it. So you can see here's our go-to-meeting tonight, all right, this 323, and I'm using a different, this go-to-meeting has a different version out now, so if things aren't where I'm used to them being, that's why. In fact, I'm looking for the pen right now and I don't see it, but I'll figure it out here in a little bit. Okay, so then here's the Read Section 2.1. I made a video up, Measurements of Growth video, where I explained the contents out of Section 2.1, percent change, average growth rates, interpolation, extrapolation, that kind of stuff. And then Section 3.1 or 2.1 is due on WebAssign. Then here are the Where Are the Jobs Lab that's due in Dropbox on 3/27. All right, so that's this week. I'm going to make a video up for Section 3.1 and then for Section 3.2 here sometime soon for you all to watch. All right, so let me just minimize that. And so that's what's due. Now the midterm is the next item up, and just to remember that the midterm is 20% of your overall grade. The midterm and final count for 40% of your overall grade. So half is the midterm and half is the final. And again, as a class, I thought we did it very well in the midterm. I was very excited about the results. If I pull up the midterm up on the test, just to indicate a couple things before we start talking about specifics, I made the midterm out of 106 points. If you actually add up all the point values for the test, it adds up to 108. And I usually, if there's a bad question or whatever, I usually just make it out of a couple points less. That helps you out. So that's what I did. So if you measure, like number 1 was worth 2 points each, so all these are 2 points each. So that's 8 points in number 1. Number 10 is worth, or number 2 is worth 10 points, or 2 points. That gives me 10 points for the page. Right there's the 10. So if you add all those up, you should get 108, but I made it out of 106. So that's the first thing I wanted to tell you. Make sure I added up all the points correctly. On each page, you should have a number beside each question, how many points you got right, and then a number at the bottom of the page, like this number 10 in the bottom left, of how many points you got for the page. Make sure I added all those up. And then whatever that added to out of 106, divide that out, and that's your percent grade for the midterm. So make sure I added those up right. It is within the realm of possibility that I didn't. I try to give as much partial credit as I can, or as I could, depending on how much work you put and how much you were heading in the right direction. I was able to do that for some, more successfully than others, but I did attempt to do that on all questions. And I think as a whole, we did a nice job showing our work. But again, I tried to give partial credit where I could. Some of the commonly missed questions, let me just pull that midterm up again and just look at some of the commonly missed questions here. And I have to warn you, this is not, when I make a test up, I make a test and I do like a rough version of it, and I make the key up and then I make any changes in pen. So this is not quite the exact same test you got. Same questions, but you'll see a couple things different. For example, on number 3, I made it worth 4 points instead of 6. So you'll see those kind of changes. All right, so The first one I want to look at, some more commonly missed questions, I'm not going to do all of them, but I want to do some of them, is number 20, is number 3. It says, and I guess you can just see the key right up here, it says, if you're driving down the interstate at 60 miles per hour and look down at your cell phone for 3 seconds to see who texted you, how many feet did you travel down the interstate without your eyes on the road? Use unit fractions to solve this problem. So you're going 60 miles per hour. How far did you go in 3 seconds? How many feet? So if I just go ahead and minimize that so I can actually write on this. So number 3 on the midterm, if I'm going 60 miles per hour, how many feet did you go in 3 seconds? Well, to go from miles to feet, and again, unit fraction, we know that 1 mile is 5,280 feet. Okay, so we know that. So now check out these units. The miles cancel, and I'm left with feet per hour. But I want, it says I'm traveling 3 seconds. So let's get those hours down to minutes and seconds. So 1 hour is 60 minutes. We know that. 1 minute is 60 seconds. So check this out now. The hours cancel. Bam, bam. The minutes cancel. Right now I'm in feet per second. And I know I travel 3 seconds. So I can even cancel out the seconds. And then if you multiply this out, the 60 times the 5,280 times 3, and divide that by 60 times 60, or 3,600, you should come out with that answer of 264 feet. So that's how far you actually travel in 3 seconds. So you wouldn't think you'd travel that far, but that's like the length of a football field. A lot can happen in that short amount of time. So obviously that's why they make illegal, texting and driving is illegal. Okay. Another commonly missed question or set of questions was number 6. So I want to look at number 6. And again, this is my pre-key here. I don't know where my other key is, so you can see a lot of scribbling and stuff. But it says in number 6, and I'm just going to jot down the information while I pull it up there so I can do it. As the latest population estimates from Census.gov, the population of the world stands roughly at 7.2 billion people, and the population of the United States is 320 million people. The land area in North Carolina is 5,300 or 53,819 square miles. If the entire world's population were put into the state of North Carolina, determine the number of people would be put in each square mile. All right, so number of people per square mile. So we know there's the world population, and this is number 6. We know there's 7.2 billion people in the world, and that North Carolina is 53,819 square miles. So if you get my parents right there, we go. If you divide that out, the 7.2 billion people divided by the 53,819 square mile, you should come up with about 133, the answer I got there, the 133,781.7 people per square mile. Okay? Okay, I just found my drawing tools. So that's what we did here. We did the number of people in the world divided by the number of square miles North Carolina is, and we got the 133,781.7 people per square mile. Good. Now, part B says, based on the fact there are approximately 28 million square feet in each square mile, does your answer in part A even seem to be reasonable? In other words, could the entire population of the world actually fit inside the borders of North Carolina without people being stacked on top of each other? Defend your choice in complete sentences. Please recall that a square foot is a square with 12-inch sides. So somehow we had to use math to justify our answer here. And we know that from before that North Carolina is 53,819 square miles. Let me just see if I can write that down here. 819 square miles. And we also know that there are approximately 28 million square feet in each square mile. So each square mile is about 28 million. I don't know if this is working better or not. Square feet. And notice the square miles cancel. And if you multiply the 53,819 square miles by the 28 million square feet, some of you did 5,280 times 5,280, that's fine. This is actually how many square feet you got. A lot. This number right here, which I just totally typed over. So that's how many square feet you got. And let's look at this. I guess that's 1,506,932,000,000 square feet. All right, that's how many square feet are in North Carolina. Now, it says the entire population, so if we divide this by the entire population, which is a 7.2 billion, one more set of zeros. So that's how many people there are. If you divide that out, you get like 209.3 square feet per person. Which is what we ended up with. And 209 square feet, that's like a room that's 20 by 10 would be 200 square feet. So 20 by 11 would be 220 square feet, so a little bit bigger than 20 by 10. All right, so that, yeah, you're not going to be stacked on top of each other. It's not a lot of room, but you're not going to be stacked on top of each other. All right, some of you did this, some of you, which is very good. Let me see if I know how to do this now. Let me go to my drawing tools. Yes, erase all drawings. Some of you said, well, you know what? I took this answer here. This is how many people will fit in per square mile. And this is how many square feet are in a square mile, and you simply divide the 28 million into, or by that 133,781, and you got the same thing, which is perfectly fine. So this 28 million on top is the number of square feet in a square mile, and this bottom number is the number of people per square mile. All right, so basically you convert it from square miles to square feet, basically, what you did. That's fine as well. Okay, but somehow you had to have some math to justify your answer there. Then in part C, it says the land area of Morganton is 19.15 square miles. If the U.S. population, so U.S., a lot of people put the world population, if the U.S. population were put inside the city limits of Morganton, determine the number of square feet each person would have. Well, this is how many miles we got, 19.15 square miles, and we know there's that many square feet in a square mile. So this is actually how many square feet we have in Morganton, 536,200,000 square feet in Morganton. You wouldn't think that, but there is. You divide it by the U.S. population, and it's like I can't tell if that's a 6 or 7, 1.7 square feet per person. Okay, let me erase those. There we go. Okay, let's go on to the next page here. I'm going to do one more thing. Again, I apologize. I'm not quite as efficient with this as we're on a new, there we go, a new GoToMeeting format, but it'll work. Okay, 7 looked good, although the big thing with 7 is it's kind of an interesting that this can happen, kind of a quirk in math, if you will. You know, if you look at the overall percentage of males being hired that applied, it was 23.1%. If you look at the overall percentage of females that applied that were hired, it was only 11%. So the males were hired at, you know, twice the percentage as females. But when you look at the individual categories, engineering, there was a higher percentage of females hired. Secretarial, there was a higher percentage of females hired. All right, so even though overall it looked like there was maybe a case for discrimination, it's not when you get down into the nitty-gritty and you start looking at the details of it. Definitely not a case there. This was a commonly missed question. I was surprised on this one. It says the full-time in-state tuition at Western Piedmont College has increased from $185.50 or $185.50 to $1,152 over the past 20 years. What percent change in full-time tuition cost, or what is the percent change in full-time tuition cost over this time period? Well, define percent change, and this is also covered in section 2.1. You have to figure out how much it went up or down by. So this went up, you know, it started at $185.50 to $1,152. So if you subtract those two, it actually went up by whatever that difference is. Let me just go ahead and subtract those two real quick. It actually went up by $966.50. So if I go ahead and pull my pen out, so it's $966.50, and divide that by the original, the 185. Always divide by the original. You get the 5.21, which you know is 521%. A lot of you just did, you know, they didn't subtract to find how much it went up by. You just did the 1,152 divided by the 185.50, and you got 621%. No, that's not the percent increase. That's just how many times one is bigger than the other. Percent increase, you have to figure out what it increased by first. Okay, number 10, down at the bottom of the page here, it says, again, I'm just picking commonly missed questions out. It says, for children under 12, the maximum safe dosage of codeine is 5 milligrams per kilogram per day. If your 50-pound child is going to take a dose of codeine every 6 hours, determine the maximum amount of codeine they should have in each dose. So every 6 hours. Okay, every 6 hours. So first you need to convert the kilograms to pounds, which, you know, are the pounds to kilograms. 50 pounds, there's 1 pound. 1 kilogram is 2.2 pounds. So that converts it to kilograms, and then you need to use this conversion that for every kilogram you get 5 milligrams. So there's 5 milligrams for every kilogram. So that is the dosage, 113.6 milligrams per day, but you just want it every 6 hours. So every 6 hours you need to divide that by 4. Because there are 4 6-hour increments in a day. A lot of you divide by 6. No, you don't want to divide by 6. If you divide by 6, you're taking it every 4 hours, not every 6 hours. All right, so you want to divide by 4 because there are 4 6-hour blocks in a day. Okay, let me go down to the next question here. Okay, so 11 was okay. 12 was actually okay. 13, this strategy game, very similar to the STD lab. It says a new game of strategy involves rolling a special 5-sided weighted die where each face is a picture of an animal. The probability of rolling each of the animals is given in the table below. Determine the requested probability. So a bird or a dog, so right there's bird, right there's dog. You just simply add 0.37. Probability rolling snake eyes. Snakes on 2 consecutive rows. 2 consecutive rows, there's a 0.19 chance on the first row. Since it's in more than one row, 2, you multiply 0.19 chance there, multiply them together because it is an and. So you're rolling a snake and a snake. Probability of rolling no cats on 2 consecutive rows. Well, if cats is 0.18, if you do 1 minus 0.18, there's an 18% chance you roll cat. That means there's an 82% chance you don't roll cat. So the 0.82. So that's on 1 row. So on 2 rows, it would be 0.82 squared. Determine the probability of rolling at least 1 cat on 2 consecutive rows. Now remember, at least, probability of at least is 1 minus the probability of none. So 1 minus the probability of no cats. So there's my 1 minus probability of no cats. We just figured out right there, 0.82 squared. Determine the probability of rolling a gram bamboo, rolling pandas on 4 consecutive rows. So pandas on 4 consecutive rows would be 0.26 to the 4th, which is 0.00457. You observe your friend roll 3 consecutive pandas. Then he decides to roll 1 more in hopes of earning the gram bamboo. Determine the probability he will roll a panda on the next roll. Well, the next roll is totally independent of the first 3 rolls, so it's just 0.26. Determine the probability of rolling an elephant on a single roll. Circle your choice. So there's no elephant, so the probability is 0. So the correct answer is 0 because none of the 5 sides are an elephant. There is a probability, it's just 0. It's not possible to determine. That part 1 there was the most commonly missed answer for this. It's not possible to determine because there's no elephant probability provided. Well, that's why the probability is 0. You can determine it, it's just 0. Okay, so that was 13. A couple more left. Let me go ahead and erase these. $14 we did well on. 15 we did well on, but this was a commonly missed. These last 2 questions were commonly missed. It says in part F, when parts B through C, they ask you to find the sensitivity, specificity, positive predictive value, negative predictive value. Then part F says if an unknown person is tested with this new swab, which test result, positive or negative, should the doctors be more confident in being correct, and explain why? Well, the correct answer is negative, and the reason why it's negative is if you look at, I'm just grabbing my pen here, if you look at the NPV, the negative values were the 84.9 and the 81.8. The NPV of 81.8 means if you test negative, you actually don't have the disease 81.8% of the time. So if you test negative, the NPV tells you that test is true. You don't have the disease 81.8% of the time. Whereas the specificity is just that backwards, saying if you don't have the disease, you're going to test negative 84.9% of the time. Well, this question clearly says which test result. All right, so you're having a positive result or a negative result. So which test result, you're looking at those 2. All right, either the positive predictive value or negative predictive value. Positive predictive value, if you test positive, it's only true 64% of the time. Negative predictive value, if you test negative, it's accurate 81, almost 82% of the time. So definitely the NPV. And then in Part G, it says the U.S. Census Bureau reports that 317 million population, while the U.S. Centers for Disease Control reports STDs in about 110. So the population is 317 million. According to this, the CDC reports STDs in about 110 million. Is this sample representative of the population? Defend your answer with the prevalence values of the population of the sample. Well, the prevalence is just the percentage of who has it. So for the population, here's 110 million out of the 317 million people that have an STD. That's 34.7%. For the sample, there's 300 people that have it out of 950 total, and that is 31.6%. So yeah, they're comparable. They're very close, very close. Okay, then coming down, looking at the bonus, I think a few of you did get the bonus. No, you got it right there. I gave a couple points out. It says create a fair game. So a fair game is that you have an expected value of 0. With the following spinner, each region has the same area. The cost to play is $5. Indicate how much is won by landing on each color and verify that it's a fair game. So fair game, you need to show that the expected value is 0. So if I start looking at these and calculate, I need to calculate the expected value. Okay, so if I do each category, so blue, I know I want to have a 1 out of 4 chance of getting a blue. I need to come up with how much I can win or lose. Red, there's a 5 out of 12 chance of getting a red, and I need to come up with how much I win or lose. Yellow, there's 1 out of 12, and I need to come up with how much I win or lose. And then green, again, there's 1 out of 4, and I need to come up with how much I win or lose. Okay, and since it's a fair game, that means that this expected value is actually 0. So the easiest thing to do in doing this and what I would recommend for you to do is just to come through here and start just assigning how much you can win or lose. For example, for blue, let's say if you get blue, you're going to break even. Okay? So you're going to win $5, but you have to pay $5. For red, let's just say you're going to lose $2. Okay? For yellow, let's just say you're going to win $5. Okay? You know this whole thing has to be 0. So what you can do is just call this X and just solve that either algebraically or figure out what you need to put in there. So you do a quarter of 0, that's 0. 5/12 times -2, 5 times 1/12, plus a quarter of whatever that value is, that the whole thing comes out to be 0. Okay, so basically you assign 3 of the 4 categories how much you win, and then the other one you just have to figure out algebraically to make it a fair game, to make the expected value 0. So that's the basics of the midterm that I wanted to cover. Again, overall, I thought we did well. Please look it over. Please let me know if you have any questions about any of it. If you want to come in and sit down, I can go over it with you. If you want to just send me some emails about questions, I'd be more than happy to respond to those. Make sure I added everything up correctly. Make sure I put the right grade in the web assign and things like that. All right, so we're at a little bit more than the halfway point now in the semester. We got the midterm for probably week 9 to 10, if I had to guess. So overall, again, I was happy with the midterm results, and overall, I think I'm happy with the grades too, overall, and the whole class. So very good, very good. Let me just go ahead and erase these drawings. And let's go to back to that. Okay, let me X out of that. Let me just minimize it. Okay, next thing on our list that I want to talk about is, so we did the midterm, talk about what's due, we did the midterm. Let's talk about this where are the jobs lab. All right, let's talk about that real real briefly. And again, you can hand these labs in same way before, either individually or as a group. All right, I'm not going to change that. I showed you how to condense Unit 1 and Unit 2 on Moodle, and I showed you where they were in Moodle. So let's just pull up some of these websites on this lab and just talk about them for a little bit before I close it out today. So let me just go back to the Moodle here, and I'm just going to click on the Where Are the Jobs lab, and it should pop up, and it does. Kind of neat talking about where all these jobs are. And you may or may not be able to see this picture that well. So I'm going to just click on this link and it pulls it up on your computer. That's one of the reasons why we put the link there. Okay. So let me just go back and find these jobs. It talks about different categories: manufacturing, construction, healthcare, all that in this article. And there's the chart. Now this chart has 3 different things that it's telling us. All right, so we have to be careful here. If you look at the horizontal scale going across, notice, let me go back to my drawing tools here. Notice that it gives me the hourly wage. Okay, so hourly earnings are going across. Now, this axis here, it's talking about jobs gained or jobs lost. All right, so if I look at healthcare, they've gained a lot of jobs. All right, so this is the break-even point. You haven't gained jobs or you haven't lost jobs. Anything above that, you've gained jobs. Anything below that, you've lost jobs. All right, so going left to right is your hourly wage. So this is the highest hourly wage on the chart. This professional and technical services. The lowest would be this leisure and hospitality. All right, now people that have gained the most jobs, healthcare, because it's further up. People that have lost the most jobs, manufacturing, which is no surprise to us in this area. Construction, no surprise to us in this area. Now, the other bit of information it tells us is the size of the circle. So the size of the circle, like this healthcare circle, tells us the bigger the size of the circle, the more jobs you have. So it tells us the current jobs as of June 2013. So notice that big circle down there is 15 million and the small circle is 5 million. Okay, so the size of the circle itself tells us how many jobs are here currently as of June 2013. Going vertically up and down, if you're above the zero here, means you gain jobs. If you blow it, you lost jobs. And then going left and right, you know, if you started here, you're at 10 bucks an hour. You're over here, you're at 40 bucks an hour. Okay, so you'd rather have, boy, it'd be nice if there was an industry right in there, wouldn't it? Because you'd be making a lot of money because you're over at the right, over at the $40 an hour. You've gained a lot of jobs, and it's a big old circle. So there's a lot of jobs there. Not only did you gain a lot of jobs, but there's a lot of jobs there that was there originally as well. Okay, so that's kind of a neat look about where our jobs are. And I kind of put an addendum on this at the end of the lab, and maybe we'll look at that here in a little bit. Okay, so when it asks you questions, let me just go back and erase some of this stuff now. Let me just go back to the PDF. So when I ask you questions like which job sector currently has the most jobs, so currently has the most jobs, that's going to be the biggest circles. So it's talking about current jobs. So it's talking about healthcare, leisure and hospitality, or retail trade. Next question, it says which job sector currently has the least job. So the least job, again, it's talking about current jobs, would be the smallest circle on here. There's actually one right there for mining and logging. All right, so number 3, which job sector pays the greatest average hourly earnings? So greatest average hourly earnings. So average hourly earnings is right across the bottom here. So the greatest would be the one to the far right, or professional and technical services, and so forth. Okay, so that's one of the charts. Kind of an interesting chart. I don't know about you, but I always take this kind of stuff seriously and keep my eyes open because I want to know what kind of jobs are out there, and I want to make sure that I'm in the area that I can get a job in. Okay, so there's some questions on that, and then it asks us to refer to this Bureau of Labor Services site, which is kind of interesting. I don't know if you've ever been in this site or not, so I'm just going to pull this up, and I'm going to show you how this site works. So there's a little bit of a learning curve, but not much. In number 10, it says, how many non-seasonally adjusted private sector jobs were there in the United States? Okay, so private sector, non-seasonally adjusted. So I'm going to click on that site, and basically, it gives me some establishment data here. Employees on non-farm payrolls by industry sector and by selected industry detail. And I believe that first question was private jobs. Let me just turn to this lab. Yeah, non-seasonally adjusted private. So right here is private. You see the total private there? So I'm going to go over here, non-seasonally adjusted. I'm going to click that box. Then we go down here, and I'm going to get retrieve data. And it's going to think a while, and that's how many jobs, total private jobs, non-seasonally adjusted, that we had during these months. And notice that these numbers are somewhere, it says, let me see if I can find it, in millions. So we have to be careful of that. It should say that somewhere. I'm not seeing it right here. But I think I asked you for December 2014. So if I go to my pen, right here is December. Right there is 2014. So it would be this number right there. All right. So that would be 119,223,000 jobs. Somewhere in here it gives the scale. Let me see if I can find that here. Okay, I just found it. It's on the page before. It's actually in thousands, not millions. So it's actually in thousands. So if I show you, let me get my pen back out, my drawing tools. Yeah, it's actually in thousands right there, in thousands. Okay, so all these values are in thousands. All right, so that's how you read that. So it talks about private jobs, and then it talks about public or government jobs. So let me just show you how to do government jobs here. It's the same idea. It's a little bit tricky to find, so that's why I want to make sure I show you how to do that. So government jobs is clear at the bottom. So you have to go at the bottom of this list. Let's see if I can find it here. Right there, government. So right there, government. So I'm going to go over here, not seasonally adjusted. Again, government. Let me just put my drawing tool up there. Right there. So do the same thing you did before. Go down here and hit retrieve data. And then if we look at that same December 2014, look at that number. It looks like it's 222.61, so it's 22261. Remember, they're in thousands, so you multiply by 1,000, and you actually get 22,261,000. Okay, so that's how you use this website. And some of these are just preliminary. We actually noticed from using this lab last semester, some of the values actually changed from a couple months ago. All right, so I'm glad we checked it again. But it asks you to do some interpolation, and find average rates of change and some percentages. It asks you to do some interpolation and some extrapolation with this. It's a neat little lab. Asks you to explain some things about the economy, which is good. Now, the last site I want to look at is the one I just kind of added on. I was just happened to find this a couple weeks ago, and I thought that would be a good one to add to this lab because it's talking about current jobs. You know, Those jobs we were looking at were from 2013, I believe, so this is current jobs. And anytime you have current data, it is much better than old data. Okay, so let me just go back to the PDF that we had. And it's an add-on. These last questions here. It says, as a follow-up to this lab, consider the more recent article found at this website includes data from 2014. Okay, so all of 2014, so it's literally just a few months old. It says, what category are those jobs added to in 2014? So if I click on that, there it goes, and it gives you this area right here, professional and business services, where the most jobs are added. Okay, then I asked you another question about what month were they added, and I give you a hint. I said, click on this active link there, that job growth. You see where I'm at right there? If you click on that, job growth, it's kind of hard to see in that light blue, but if I click on that, it actually goes in a little bit more detail. You can watch the video if you want, but it actually goes in a little bit more detail about, you know, what months most of the jobs are, what month the jobs are added, or what, you know, how many jobs are added each month. All right, so you can go into detail on that. And I think the third question asked you about that particular histogram right there, or bar graph, I should say, as well. So interesting little lab. I mean, to me, that's a big area I'd be concerned about. You know, what kind of jobs are out there in my area? I know that's something I looked at seriously, and I also like, how much are we going to make too? You know, that's also equally as important. You know, ideally, you want to be somewhere, you know, ideally, obviously to the far right as you can, but, you know, it'd be nice to get something, you know, it'd be nice if we got some industry in here that in North Carolina that we gain a lot of jobs and that pays well. That'd be real nice. That'd be real nice. Okay, so let me know if you have any questions on this lab. It'll take a little bit of time to complete. It's not something you'll complete, you know, in a couple hours, so it'll take a little bit of time. Let me know if you have any questions on it. That's due Friday in your Dropbox. Your WebAssign 2.1 was due on is due on Wednesday. Let me know if you have questions on that. I think the video I put out was pretty good. It has the different types of questions on there that it's asked about. And also, if your midterm, if you have any questions about your midterm, please let me know. If you want to come in, sit down, and go over each and every one, I'd be more than happy to. If you just want to email a couple quick questions, I'm more than happy to respond to that. You know, whatever works best for you. Thank you very much, and have a good evening.